Okay, this video is going to show you how to find rational zeros. This is a 2.0 objective, and the next video will show you how to use this at the 3.0 level. Here is the rational zero theorem. You'll want to write this down on your note sheet. Here's the most important part. I like to call this the P over Q theorem. So go ahead and jot this down in your notes. Pause if you need to have more time. Okay, so here's for your first example. List the possible rational zeros. It should say of f using the rational zero theorem, so I'll plug that in there. Sorry about that. So of f using the rational zero theorem. So here's your f of x function, and we're going to use that p over q theorem from the first slide to write out the possible rational zeros. Rational just means that it can be written as a fraction. That's what a rational number is. So for this first example, to find our possible rational zeros, we're going to start with the factors of the constant term. That's what this P stands for. So we're going to look at this 12, and we're thinking of all the factors of 12. Well, we have 1 and 12, and we have -1 and -12. So on all of these, I'm going to use a plus or minus. We have plus or minus 1, plus or minus 12, plus or minus 2, and plus or minus 6, and plus or minus 3, and plus or minus 4. And I won't do that like that again because I almost ran out of room. So we have 1, 2, 3, 4, 6, and 12, and then we have -1, -2, so on and so forth. So that's where that top number comes from, is the factors of this last number, this constant term, the one without a variable. Your Q are the factors of your leading coefficient. Well, our leading coefficient here is 1. It's not shown, but we know that's what it is. And the factors of 1 are just 1 and -1, so plus or minus 1. Well, so now we need to go through and simplify this. So we have plus or minus 1 divided by plus or minus 1. Well, that doesn't do anything. And in fact, dividing by positive and -1 is not going to change any of these. So our possible rational zeros are these right here. So as you can see, that's a lot of numbers. That's 6 numbers and their opposites, so a total of 12 possible numbers that could be the zeros of this function. But we know, because we're smart, that there are only a possibility of 3 real numbers, because this is a degree 3 polynomial. So only 3 of those could actually work. Let's do another example. Okay, so here is another function f. So once again, this should say of f. And we're going to find the possible rational zeros of this. So same thing, we're going to do p over q. Our p stands for our possible factors of 10. So we have plus or minus 1, 2, 5, and 10. So 1 times 10 is 10, 2 times 5 is 10, so on and so forth. And then our q are our factors of 4. So we have plus or minus 1, plus or minus 2, and plus or minus 4. We have 1 times 4 and 2 times 2. Okay, now we have to actually simplify these because we're not just dividing by 1 this time. We're dividing by 1, 2, or 4. So this is how I like to do it. I like to go through and I like to start with this first number on top, plus or minus 1, and I like to divide it by each one on bottom. So I do 1 over 1, so plus or minus 1, 1 over 2, plus or minus 1/2, 1 over 4, plus or minus 1/4. And then I would go on and I would do this next one, plus or minus 2. And then I do that over each one of the ones on the bottom. So plus or minus 2 over 1 would be 2. 2 over 2 is 1. Well, we already see 1's on our list, so we don't have to rewrite that. 2 over 4 would be 1/2, also already on our list, so we don't have to rewrite that. So then I'm going to move on, and I'm going to go ahead and do the 5. So 5 over 1 is 5, so plus or minus 5. 5 over 2 is 5/2. And 5 over 4 would be just 5/4. Okay, now we're ready for the 10. So 10 over 1 is 10. 10 over 2 is 5, already on our list. And 10 over 4 is 5 over 2, also already on our list. So then this is our complete list. I'll go ahead and move this plus or minus 10 up here. That's our complete list of possible rational zeros. So at the 3.0 level, you'll see what to actually do with this list. But at this time, that's as far as we're going to take it. Thank you.